Okay, class. In this video, I would like to go through I put it here, the chains of rule. I'm so sorry. This is the chain rule. I don't know why I did that. Excuse me, guys. This is, okay. And I think that in other videos, I mentioned that the chains of rule. I'm so sorry, guys. Okay, it's the chain rule. Well, the chain rule is one of the procedures that we need in order to compute when we have composite functions. Okay, so for instance, if you have a function that is the composite of g and f, remember that in some other notation, this is f, g, s, okay? And the meaning of this is the composition of the functions g and f. So what is the meaning of this? That you are going to evaluate the function f within the value of gx, as you see in here. Of course, when we are doing or when we are performing that operation, we are assuming that the image of s through the function g belongs to the domain of f. Okay? But this is basically when we have that situation, the question is, how can I compute the derivative, okay, of this composite function? Okay, how can I compute this? What is the rule that we need to follow in order to make that computation? And it's a rule, okay? It's nothing else. It's a rule. It's something that you need to just to learn. I don't want you to memorize, okay? And believe me, if you make 3 or 4 exercises, you're gonna remember automatically. You don't need to memorize that. And the reason that I don't want you to memorize this is because at the end of the course, we're gonna have so many rules, so many formulas, and it's gonna be impossible for you to memorize those ones. But if you are understanding what you are doing, there is no any problem, no issues for that. So, well, what is the rule? The rule is the following. So the derivative of the composition is going to be the derivative of the external function, which is this one, evaluated into the internal function, evaluated into gx, multiplied by the derivative of the internal function. That's it. Very easy. Okay? That's what you need to do. And you need to remember. So, is the derivative of the external function, the one that is more to the left, evaluated in the internal function, the inner function, in here, times the derivative of the inner function, which is this one. That's the rule. That's the chain rule. Okay? So, in here there are so many notations. This is something that we use to apply, to remember this chain rule, but I don't want to introduce so many notations because you're going to get confused. I think it's better to make one exercise in order to understand what we are doing. So we're going to start making the derivative of the external function evaluating to the internal one. And then you multiply by the derivative of the internal, of the inner function. That's it. And you will apply this as many times you need depending how many functions are taking place in the composite. Okay, so that's basically the rule. So then, well, we have this colorario from here that is very easy. I'm not going to go through this because that is something that is just a derivation of the rule, okay? And that is something, if you know the rule, you're gonna be able to do this, okay? That is not a problem. Okay, so in your textbook, you will see this function, okay? This function is the composite of three functions, okay? The external one is the sine function. Then we have a middle function that is the exponential. And then we have the most inner function, okay, or internal function, that is the cosine. So let's see how the derivative of the whole function looks like. So, well, I made here the derivation of that. Let's go through that, okay? So the function is called y, so we are computing the derivative of the function respect to the variable, the independent variable. The independent variable is x, okay? And that is the derivative of y, which is all of this, respect to the variable x. So we have here the addition of these two functions. So we apply the rule of the addition, the derivative for the addition. That is going to be the derivative of this one plus the derivative of this one. That's what I did over here. That is the derivative of this function here, okay, and the derivative of this function that is constant. But the derivative of a constant function is 0. Okay, so don't worry about that. Okay, now we're going to start applying the chain rule from here to compute the derivative of this composite function that we have here, sine evaluated in the exponential of 1.3 times cosine. As you can see here, we have this external function sine, this middle function, the exponential, and the inner function, the cosine. We have three functions, okay, the composite of three functions. So, how we apply the chain rule? Well, this is the derivative of the external function evaluated in whatever we have in the argument. So the derivative of the sine is the cosine function, evaluated in the whole argument, which is this one, the exponential rise to 1.3 cosine the x, of cosine of x, times the derivative of the internal or inner function, the derivative of the inner function that is in this case the exponential that is rise now to this argument. Okay? So, well, so we have, this is coming from this first part, this is coming from this, we keep this one, then the derivative of the exponential function is itself, if the exponential function evaluated in the inner function, which is 1.3 cosine of s, times the derivative of the inner function. What is the inner function? Is this one here. So is the derivative of the inner function. Okay? Now, we drop all what we have in there because we need to keep those factors. That is the the result for the previous steps, times the derivative of this one. This is the derivative of a constant that multiplies a function. So this is the constant multiplied by the derivative of the function. The derivative of the function cosine is minus sine. So I put it here. I put it here sine, and I brought the minus signs at the front. Okay, minus sine s times 1.3. So now what I'm going to do is just to reorganize a little bit this. Okay, I'm going to bring the coefficients to the front. So I have here minus 1.3 times cosine of the exponential of 1.3. I'm sorry, this is 1.3 cosine x. I mean, this cosine is in the upper part. Okay, so this cosine is here. I'm sorry. Okay, this cosine is here. It's part of the exponent, as I made here. Okay, is this one, and this cosine is multiplied by 1.3. Okay, so it's that one. The sine function multiplied by the exponential rise to 1.3 cosine x. So at the end, let me just put this a little bit more clear, is 1.3, and actually I'm going to bring this exponential here, exponential of 1.3 cosine x times cosine of s 1.3 cosine x times sine s. And this is the result. This number here is 1.3. Okay, so let me just to make it clear to avoid any type of confusion. This is, oops. One. 0.3. Okay, and this is the result. So in here we have really the composite of three functions, and what I did was to apply the chain rule as many times I needed. So I applied the chain rule 3 times. Okay, from the external to the most or innerst function that we have in the composite. Okay, well, that is the chain rule. Okay, and is one of the last bullet points that we have for the techniques to compute the different the derivatives. So now we know how to compute the derivative of powers. We know how to compute the derivative of additions and subtractions. We know to compute the derivative of products, and also the derivative of ratio of functions. Ratios of functions, and we know some derivatives for some transcendental functions like the trigonometric functions, and also the exponential functions. And now, the last one, we know how to make the derivative of composite functions, which is the chain rule. Okay? Well, this is what I want to tell you about the chain rule. Nothing else. Thank you.